Hello everyone, welcome back to this channel. Let's continue feature transformation. As of now, we have completed scaling, log transformation, box cost transformation, how to encode categorical variables. Now we are going to understand what is binning. Okay, binning means converting continuous features into categorical ones by dividing them into intervals. Suppose you have a continuous features and you want to create a category of them. Okay, see here the example. Here I have a column named age. So we have age of many persons, right? Now you want to create a category of this age column. So how can you do this? So you think that if the person's age is 0 to 18, the person is child. If the age is between 18 to 35, he is youth. If the person's age is 35 to 50, that person is an adult. 50 to 65, then middle age. 65 to 100, that is senior. So simply you have created some intervals and then you have made them a category. Okay. Now you take the age 22. So the 22 will come under 18 to 35. So the person is youth. 25 youth. 47 adult. 35 youth. 46 adult. 50 middle aged. 65 senior. 68 senior. 70 senior. 45 again adult. Okay. So you have age, you have the continuous column, you have the continuous features. Now you want to convert them into category. So you have converted them into category by creating an interval. Fine. Now let me show you the code. See here, this is the code. You have column named age and you have all the ages of persons. You have converted them into data frame. You have created bins and you have also created labels for them. Okay. Now you convert this numerical columns into this category. Now let's do it in Colab. First, just check the data frame once. And we have defined the bins. We have defined the labels. Okay. Now we have to write BF. Within this, we can write age group PD dot cut. Cut function will create the intervals. And here we are providing the age column, bins equal to bins, levels equal to levels. Because we have mentioned here as bins and levels. So this will become the bins and this will become the levels. Child, youth, adult, middle-aged, senior. Okay, now let's run this. But before that, okay, we have imported pandas. Then fine. So just run this. Okay, now let's see what is DF. See, so you have created 5 categories. So if you have many ages, all of them will be converted into 5 kind of categories. Sometimes you may need this kind of columns for your machine learning algorithms. So in those scenarios, you can simply convert these continuous features into categorical. Okay. Now if you want to visualize this, SNS dot count plot x equal to age group and data equals to the data frame. I'm very sorry. Import C1 as SNS. Now, see child because there is no person in child category. Youth, adult age group, middle aged, senior. So you can easily understand that maximum are adult. Okay, no child. Visualization is always easy to interpret. Now, if you want, we can create his plot also. So import matplotlib dot pyplot as plt. You can create by C1 also. Anyway, plt dot hist plot. Sorry, hist df df on age underscore group. Right? Now let's run it. See, as there is no one in child group, that's why It is not shown here. Okay, so you can use his plot, you can use count plot, and you can analyze your data. Anyway, the main part is converting the features into categorical ones. Okay. Now our topic is reciprocal transformation. Transforming features to reduce skewness and to manage large differences in scale. And this transformation is particularly useful when the data has a skewed distribution with a long tail towards small values. Now, suppose if you have two numbers, one is 50 and the other one is maybe the other numbers are lying between 15 to 35, like that. In comparison with them, these are extreme. Small values, large values. Now, suppose if you make the reciprocal, then what will happen? 1 by 50, right? Reciprocal of this one, 1 divided by 2. 1 divided by that number is the reciprocal number. So now the output will be 0.02. Here the output will be zero point 0.5. So now this one has become larger from this one. Okay. And they are comparatively closer to each other than before. Okay. So here what we do? We make the reciprocal of each data points so that the larger value becomes smaller, the smaller value becomes larger. That is also done to reduce the skewness. It's simple. Just we have taken a value. Just let me show it to you. If I just paste here and see, let me run this. See here what happens. 1 divided by 1, 1. 1 divided by 2, 0.5. 1 divided by 5, 0.2. 1 divided by 10, 0.10. 1 divided by 20, 0.05. Okay. So this is also a type of feature transformation. Now let's understand what is polynomial features. Polynomial features means creating new features by raising existing features to a power or by multiplying them together. Let me show this to you, then this will be clear. Just copy. Now see, there are two features, 1, 2, 4, 5. Fine. Now, polynomial features is the function. You have to mention degree. First, let me give it and it will be easy for you to understand. Okay. Now we have just applied fit transform. We have applied this many times before by calling this object. First, we have created an object of polynomial features class and then we have applied fit transform. So what happens here? First, we are taking the squares of first feature. Then we are multiplying the features. Then we are again taking the squares of the second features. Okay. Now, if you want, you can simply increase the degree by writing degree equals to 3. Okay, same. First square, then multiplication 1 into 4, 2 into 5. Then again square, 4 square 16, 5 square 25. Here I have written the rules. Feature 1, feature 2. Feature 1 square, feature 1 into feature 2. Feature 2 square. Next feature 1 to the power cube. So 1 cube, 1 to the power cube, 8. Fine. Next, feature 1 square into feature 2. Feature 1 square means this one. 1 and 4 into 2. So 1, 4 into 2, 8. Fine. Now again see. Feature 1 into feature 2 to the power square. So what is feature 2 to the power square? 16 and 25. So you have to multiply 1 into 16, 2 into 25. So you can see 16, 50. Okay. And again last one, feature 2 into, sorry, feature 2 to the power cube. So we can do 4 to the power cube. 4 to the power cube means 64. 5 to the power cube means 125. Okay, so this is also a way by which you can transform your features. This is known as polynomial features. Okay, you can just follow this formula and then you can understand. You just have to call the polynomial features class. Okay, and it is used when dependent and independent variables are non-linear. Okay, when you will understand SVM algorithm, support vector machines algorithm, there it benefits a lot. Okay, now let's understand interaction features. Interaction features means you just have to write interaction only equals to true. Nothing. Uh, let's first make it true and interaction only equal to true. Then see what happens. Just a small change. Hmm. Yeah, I have forgotten a comma. Just a small change. Just the multiplication. Okay. So you don't do the power change. You just multiply 1 into 4, 2 into 5. So depending on your need, you can call the interaction only parameter or you can do the complete transformation. Here it is done both power and multiplying together. But here only multiplication. Okay. So we have understood many techniques of feature transformation and all this will depend on your need. As per your need, you have to transform the features. All these things are done before you model your algorithm. Okay, and in our next class, we will understand how to do feature extraction. So, meet in our next video. Till then, bye. Happy learning.